I said in a previous lesson that trinomials are written in the form ax squared plus bx plus c, but then after I said that, we really just focused on the b and the c because a has always been 1. But sometimes a is not 1, as you can see in these two equations. And so, not equations, expressions. And so now a is going to start to matter. So a is 5 here, b is 27, and then c is 10. And so what I'm going to show you is how to solve these problems using factoring by grouping, which takes us straight to the answer. You've done factoring by grouping before. Factoring by grouping is the technique we used when you had 4 terms and you grouped the first 2 and then the last 2, and you ended up getting a set of parentheses that was the same in both sets. So, as with all factoring, the first thing we check for is a greatest common factor. Do we have one with 5, 27, and 10? No. So, step number 1 for this problem, step number 1 is we multiply a and c. We do a times c. So a is 5, c is 10, so we do 5 times 10, which is 50. Okay. So 50 is going to be the thing that we're using as our product. Our product is 50. So step 2 is going to be to find two numbers with a product a times c and sum of b. So in this problem, what that means is the product equals 50 and the sum, b is 27, so the sum is 27. Now you should be pros at this by now, either of knowing your multiplication well enough to go straight to the two numbers, or making that table with the product on one side and the sum on the other until you find them. In this case, the numbers are 25 and 2. 25 times 2 is 50. 25 plus 2 is 27. So those are our two numbers, 27. Okay. So here's the part where we go from a trinomial into a 4-term polynomial, and this is step 3. Step 3 is split bx into 2 terms using the numbers from step 2. So our bx was 27x in this original problem. So here we're going to split it. 27x is going to become 25x plus 2x. Okay, so let's go back up to this problem. It was 5x squared plus 27x plus 10. This is going to become 5x squared, and then our 27x gets split into those two terms. 5x squared plus 25x plus 2x plus 10. The 27x gets split into two terms based on those two numbers we found. And then step 3 is something that we've already learned how to do before. Step 3 is factor by grouping. And you know how to factor by grouping. We have done that in a previous lesson, factor by grouping. So those are our 4 steps. Let's go ahead and finish it up. So factoring by grouping means group these first two terms together, 5x squared and 25x. They have a greatest common factor of 5x, leaving us with x plus 5. And then our second two terms are 2x plus 10. They have a greatest common factor of positive 2, leaving us with x plus 5. The set of parentheses that they have in common is x plus 5. And what do they have left over after we take out the x plus 5? 5x plus 2. So there's our solution, 5x plus 2, x plus 5. And that is our solution when we factor this completely, x plus 5 and 5x plus 2. Okay, let's look at this second one. Again, just like with all problems, when we factor, we start off by searching for a greatest common factor. Is there a greatest common factor in this problem? Yes. 4, 24, and 32, they do have a greatest common factor. 4, 24, and 32 can all be divided by 4. So we put a 4 outside our parentheses, and then what's left after we divide everything by 4? So 4x squared divided by 4 is x squared. 24x divided by 4, well, 24 divided by 4 is 6, so 6x. And 32 divided by 4 is 8. Well, this works out really, really well because now what is left inside these parentheses, the leading coefficient is 1. 1x squared plus 6x plus 8. So we can go straight to our two parentheses. Our parentheses start with x because it's x squared. And now we need two numbers that when we multiply, we get 8. And when we add, we get 6. And those numbers are 4 and 2. What do we do with that greatest common factor of 4? It stays right out in front. And this is our solution. So just because it has a leading coefficient that is not 1 doesn't automatically mean we factor by grouping. If there's a greatest common factor, sometimes the greatest common factor gets it back to plain old x squared, like in this problem, which is great. But if there's not a greatest common factor, or if there is a greatest common factor, but after the greatest common factor, you still have a coefficient on x squared, then we do factoring by grouping. You take that middle term and you split it into two terms, and then you factor by grouping, which we've learned how to do before. And how do you know which two terms to split the middle one into? You do A times C, the first number times the last number, and that helps you find what your two numbers you split into will be. They must have a product equal to A times C and a sum equal to B, and that's how you tell what to split B into, and that's how you get your four terms for factoring by grouping.